All right, you may remember we had actually started some of this content, I believe, on, well, it was yesterday, I believe. This was up on the board, and I just happened to still have it up here because not everyone had the opportunity to be sitting in this class. And what we had discussed is a lot of these organic families will come full circle, okay? And if you remember from the first week of school, we had categorized a lot of these organic compounds into their associated families. And I think when I started, I actually had an alkane up here. So I just want to briefly go through. And I think it's always a good idea to always continually review and go over different types of aspects that we have done in the past, just to reaffirm what you have already worked so hard to learn up to this point, okay? So with this, if we were to cover that up, okay, everything's single bonded, so we know that that is an alkane, and we still continue to use the prefix that we've used up with naming any of these, whether it's an alkyne, an alkane, or an alkene. And with that, since we are dealing with alcohols, we know that that is the organic family for this compound because it has this OH. It wouldn't matter whether it was on any one of these carbons because it would still be the same compound over here, but it would just have a different name if that OH group was on here. So if this was propane, well then we would call this compound then propanol, because the OH then is making, or excuse me, the OL is making reference to the OH then. When it comes to ethers, okay, these are a little more tricky. We will actually form some of these, and if my memory is correct, it depends upon what type of alcohol you react that with and what temperature it is. And again, that information will be provided to you because I believe it is on those flow sheets, flow charts, whatever you want to make a reference to with those. And hopefully you may agree that that was a, what do I want to say, a useful tool to help you get through probably some of the most complex and difficult material, and that was the aromatic reactions. Okay, but moving on with this of what we call an ether, and we know that it's an ether because we've got this single bonded oxygen and carbons on both sides. And it's not a carbonyl carbon unlike these three here. And if you remember that carbonyl atom or carbons, because there's a double bonded oxygen on there, that is not the case here. One of the compounds we don't have up here is that of an ester, and that is correlated to these, but that is probably where we'll start when you come back in January, is that with the ester formation. Excuse me. Okay. So when it comes to naming these ethers, it's a little different. We've got this oxygen in the middle, and we've got a methyl group and an ethyl group on both sides. So then we just put them in alphabetical order, and we would have what you call as an ethyl dash methyl ether. Okay? So again, you just find the center, name your derivatives on both sides. So this is a review. It's an alkene, of course, and we don't have to put a 1 after this unless you really wanted to. And of course, no surprise, propene. Okay. Then when we go over here, still a 3-carbon compound. We know it's an acid because we have COOH, that double bonded oxygen. The prefix is still the same. Okay. Then our suffix changes because it is an acid, so it is OIC, propanoic acid. And notice there's nothing branching off these parent chains. I think it's important just to actually understand that just the very basic one. For the same reason, if we were just doing butane, okay, we don't have anything branching off of there. I think we'd just rather start with learning the basics with that, or the fundamentals, that's the word I'm looking for, to understand this, and then maybe get a little more complex in the future. All right. Here, as we can see, we got an aldehyde because, yes, it's got a double bonded oxygen on the first carbon, but it does not have an OH group on there. Okay, the prefix is still the same, but rather than being OL like an alcohol, it's AL because, again, it's an aldehyde. Then finally, as you can see, for those individuals who were in here yesterday, we had said you probably wouldn't use the scientific name here very often because this is, again, known as acetone, but the scientific name then, just with the same pattern, 3 carbons every time, we would actually call that propanone. And I hope you can see that with these suffixes then, all right, the OL, the alcohol, the ONE for the ketone, the AL for the aldehyde, that a lot of the suffixes will point to what it is that you're actually referring to, what type of organic family. Since this has ONE in it, this has AL, that there's some sort of correlation between the organic family and that of the name. All right, so that was a brief introduction to what we had done yesterday. So we had mentioned we still have a job to do, and just want to continue to move forward. We've worked so hard up to this point. Let's not stop now, and that's what's carried you into the postseason for your volleyball career. Okay. So as we move forward here with that of the alcohols, of course, there's probably always going to be different types of, what do I say, industrial uses. We really don't go into it that far in depth because we just want to learn how to name these and then utilize and understand the reactions that would be correlated with them. Okay, so alcohols, as you can see, we already know that's got an OH group or hydroxy compound, and this has a single bonded oxygen somewhere. Then this is a little bit of review. The author chooses to include that. Really don't talk about phenols very often. Remember, that's just an OH group on a benzene ring. And when you look at that bottom point or dash, what it's saying, remember that is not a negative ion there, like what you learned in general chemistry with that of the hydroxide portion. Okay, it's just the way that it hooks up to the carbon atom that saturates it. And notice there are no carbonyl atoms in here because, again, this is just single bonded between it. The parent chain is still saturated, but there is no double bonds, therefore not making it a carbonyl atom. So as we continue moving forward, while some of you are out in Huron, we try to keep these fairly short. And the idea behind this is, and we had discussed this in the email, and I think you would agree that's in your best interest. We'll try to keep these short so that once you do get back, we can hit the ground running, you can get caught up on your time and at your own pace and decide how it is you want to continue to move forward.
Oh, you're zooming.
Recording.
Oh, sorry.
Oh.
I thought the students were there.
Oh, nope. No problem. Okay, Mr. Deitch sends his regards, so best regards. Okay, so as we continue to move forward, I think I wanted to go through 2 slides. Yeah, just down to here, and we'll probably discuss this tomorrow, okay? And probably a lot of the industrial uses with this is just as an additive. Of course, we all know with that of gasoline, or could be in maybe some sort of medications. I believe phenol is a type of, I think it keeps tissues from growing. So not only is it an antiseptic, it would keep bacteria from growing. I do believe it does that very well, but also I want to say in your fingernails or toenails, I believe that phenol could be added, and again, works very well as an antiseptic. I think it keeps the nail from growing. Okay, the last thing I want to do is, again, I want to try to keep these under, and again, that's just try. I see we're at about 11 minutes, so that is where we will stop for today. I just want to go and write a little bit of information down, okay? Because again, the more you can scout and see this, the better off you're going to be. And I hope you believe it, and I think you probably do, that whether you're in this room or Ms. Doctor's or Mr. Deitch's, we are looking out for your best interests. And I bet you they're asking me to take roll, but nobody's here. So hold that thought. Yeah, I didn't take roll because they're all out in Huron. Oh, yes, that's true too. Okay, I will get that done.
Okay, no, I can do it. Are they logged on?
Yes.
Okay, I will mark it. Thank you.
Yep. Okay. So again, the more you can scout and see this, then the better off we will be. Okay, so these I think would help if they're just a little bit longer. Okay, so of course we would know that as being butane. We'll just do 2 of the 3 right now. Okay, so when we look at this, if this OH is on the end, not only did we change this from butane to butanol, this is what we call primary alcohol, okay? And the reason is because when we say X marks the spot, what makes that organic family is only attached to one other carbon. When we say X marks the spot where that attaches, that is only attached to one other carbon here. Therefore, this is a primary alcohol. And the reason that's important is the primary alcohol will follow a different pathway than a secondary alcohol will. And that is noted on your flow charts when we get to that when you return. Okay, so for instance, doesn't matter where we put this OH group, either here, here, or here, so we'll just put it right in the middle. Okay, not only is that a different name, okay, but this is now a secondary alcohol. Again, just like what we said, X marks the spot. Here we can say same thing here. Where that OH group attaches to a carbon, that's attached to 2 other carbons. Therefore, this is a secondary alcohol. Okay? And again, just because this is attached to, if you want to look at it, 2 other carbons, secondary. Only one a primary alcohol, and then we'll get into the third one, that of tomorrow. And then the more we see the naming of this, I think we'd be better off as well. As we said, this would be pentane, but since we have that OH group on there, if we had pentanol, just like if we had butanol up here, what we're saying is if there's nothing written in front of here, it's just understood that it's on the end. So if we were to say pentanol, we'd say there's an OH group here, here, or here. But that is not the case. So therefore, the last thing we need to do is just say, well, where is that OH group located? Doesn't matter which way you go, it's still on the third one. So we would just say 3-pentanol. And again, if there's nothing written after a number, what that means is you're either referring to where a double bond is located or where an organic family is located. That's the case here. The 3 is making a reference to where that hydroxy group is located on that third carbon. Okay, so that's all I got for today. We will catch up to you next time.